Hello and a very warm welcome to part 2 of this Regentone model DP2 repair series. The local weather is bitterly cold, which is to be expected now midwinter is more or less upon us. The plastic cabinet has cleaned up reasonably well, and my wife has made a decent job at cleaning the dust and debris off the chassis. We will now take a look. Reasonable, don't you think? This chassis is suitably clean to work on. I'll likely give it a deep clean sometime after I've gotten the radio functioning. The rear cover has most certainly cleaned out well. And as for the valves, they are gleaming once again. The long wave and medium wave band's tuner plate is in a deteriorated condition. Much to my wife's annoyance, I'm a bit of an hoarder. I have saved a rear tuner plate that is in quite good condition. I'll save this original one for a few very lengthy reconstruction sessions on the computer. I genuinely believed I had a replacement brass skirt for the tuning knob. In part 1 you will remember me saying there was a likelihood this tuning knob's neck would be broken. As you can see, it is broken. Removing all of this gingery brown coloured dried on contact adhesive has potential to be a lengthy chore. Over the past 40 plus years I've seen and repaired several of these DP2s, and in all of those years it's doubtful I've seen more than 4 or 5 that were intact. It's fair to say an inevitable weakness, though not unique to Regentone. There are plenty of other makes of radio incorporating the same or similar type of tuner adjustment arrangement that suffer the same or similar type of problem. Since I have the lower piece of severed neck, I might be able to effect a reasonably strong and lasting repair. Before moving over to that which I regard as being the interesting side of vintage radio restoration, the electronics, I'll execute one very small but vitally important task, and that will be to check whether or not the ether ballast resistor is OC. That is, in the audio and television servicing trade, shorthand for open circuit. According to my digital avometer, the heater ballast resistor reads as OC. So why have I singled out that particular resistor? Having repaired scores of these DP2s over the past 45 years, one becomes familiar with the likely faults associated with this model of radio. Consulting the circuit diagram for this radio, the heater ballast resistor is R15. and the resistor values list tells me its value is 980 ohms. I'll rummage through 2 or 3 of my way wound resistor bins to see what I've got. Having done some rummaging through the plastic bin on the right, I found this 1K way wound resistor. Though it is 20 ohms over the specified value and it is not up to the required wattage, it will nonetheless suffice for the present. I'll return this lot to the receptacle from whence it came, and then I'll fit this way wound resistor into place. Having returned the 2 way wound resistor bins to their rightful place, I fitted the mains lead and the 1K way wound resistor that is acting in place of the defective heater ballast resistor. Being a temporary arrangement, I wrapped the resistor wires round the terminals. I haven't soldered them since I'll need to liberate it sometime in the future. Moving on, I felt it was time to give this chassis a routine inspection. There is no visible sign of repair work. The rotation of the volume control and switch action feel to be working fine. So does the action of the band switch. Rotation of the tuning capacitor is excellent. There are no visible signs of readjustment to the IFTs and associated trimmers. They look factory aligned. The reservoir and smoothing capacitors will be replaced. The Hunt's Duramold paper capacitors, there's one there and there's another one just there. They will be replaced with polyester film types, and all the carbon composite resistors will be tolerance checked. Come sooner or later, these AC connecting wires will need replacing. Exposure to heat has caused their plastic sheathing to become brittle, and the ends of the wires are in an oxidized condition. Having executed those minor checks, we will take a closer look at the circuit diagram. Emphasis will be upon the power supply circuitry. Now over to the circuit diagram, which is on service trader sheet 1283. In part 1 I stressed that electricity is lethal and not to take chances. Since 240 AC mains voltage along with 250 plus volts DC high tension is present in valve equipment, excluding domestic battery valve equipment, yours and everyone else's safety is of paramount importance. If you are following along with whole or any part of this Regentone model DP2 repair series, you do so at your own risk. Please be warned. For those of you who remember my repair modus operandi from previous videos I've uploaded, I begin by getting the power supply circuitry operational. By doing so, I'm able to power up any part of a radio that I happen to be working on. Something I've done since my early apprenticeship, and have continued doing so for well over 40 years. Excuse me whilst I take a quick squeeze on my Ventolin. That's better. In brief, starting with 240 volt AC input via double pole double throw switch marked here as S5 and S6. There should be no reason with the use of a moulded 13 amp UK mains plug and pre-attached mains lead to reverse the mains polarity, as was the possibility when this radio was new, provided the blue neutral wire is connected directly to deck or chassis. The brown live wire is connected to dropper resistor section R17, which is a 14 ohms for voltage adjustment. Since UK mains voltage is universally 230/240 volts, appliance with mains voltage adjustment should be set accordingly. C27 and C28 being the suppressor capacitors, each are valued at 33 nanofarad. The valve heater circuit is a loop via ballast resistor R17. Which has already been mentioned in a little earlier on. One reason for the series heater arrangement V4, V1, V2 and V3 is to reduce hum. R16 150 ohms anti-surge resistor allows a slightly reduced mains voltage onto pin 9 of V4 anode UI 85 rectifier. From V4 cathode pin 3, row or 50 cycle DC is filtered via reservoir capacitor C25 32 microfarad. It passes through unbucking winding of T1 audio output transformer and is further filtered via pi topology or a low pass filter R13, yes R13 2.2k resistor and smoothing capacitor C24 32 microfarad. From there it goes on to form the HT rail. You may have heard or indeed said, a little of that which you like does you good. Well, I enjoy a little bit of shop engineering. I'm not saying or implying that I'm any good at it. I'm just saying I enjoy it. And I'm feeling a lot better for having done so. I'm not so out of breath. I do not normally restuff capacitors, unless of course requested to do so. In this instance I'm placing, not restuffing, 2 new electrolytic capacitors inside this empty aluminium canister. Why am I doing this? Purely for ease, certainly not for aesthetic appearances. I did not cut open the canister, nor did I prise up the folded ends. So, how did I draw this capacitor's entrails? I do not recommend my method I'm about to briefly tell you. It will likely be dangerous if you do not have access to a bench or a floor-standing power drill and a power drill vise that is secured to the drill platform. I wrapped a fair amount of newspaper and masking tape round this canister. Then I wrapped a couple of layers of cardboard and then wrapped a rag round all of that before I secured the well-wrapped canister into the machine vise. Having set the drill stop to 3mm clearance between the tip of the drill bit and the close end of the canister, I then use a 7/8 drill bit, rotating at the slowest drill speed to gradually remove most of the entrails. Having done that, I poked out what was left inside the canister with a flat blade screwdriver. As I have said a few minutes or so ago, I do not recommend you do this method unless you have some shop engineering experience. All I'm going to do here is line this empty aluminium canister with felt cloth and place the two new electrolytic capacitors inside. Nothing more. Here we go, capacitor canister done, dusted, and now ready for refitting to the chassis. The reason I fit new electrolytic capacitors inside empty canisters, like I did here, is purely for ease. It may appear strange when looking at the rear of this chassis, but space from the centre to the bottom is somewhat scarce, very scarce. Locating a suitable position for fitting the two replacement capacitors as close as possible to the bottom of this chassis, away from rising heat, proved a greater challenge than I was prepared to accept. The two capacitors would have got in the way of the chassis to cabinet screw fixing lugs, be very close to other components, or run an immense risk of scraping alongside the volume and the band switch controls. Given those potential problems, my way of thinking was to place, not stuff, the two capacitors inside this empty canister. All that anyone needs to do when replacing the two capacitors, say in 20 or 30 years' time, is unsolder the connecting leads, remove the canister from the chassis, and tug on the three leads to extract the capacitors. Hopefully it will be as straightforward as that. Now, being the thrifty little soul that I am, I retained the two solder tags from the old capacitor shortly before I drilled out the contents. They will definitely come in useful as chassis solder tags for some future project. Not wanting to allow grass to grow under my feet, canister refitted, and capacitor leads soldered onto their respective valve-based pins. I suppose you, like me, have those days when it feels like one step forward and two steps backwards. Well, this could be one of those days for me. Having applied my digital AVO meter to test the continuity of the audio output transformer and unbucking winding, I'm now faced with having to replace the entire transformer since the audio output primary winding reads OC. The time now being 5 to 2, I'll bid you a good morning. The audio output and unbuck combined transformer will have to wait until tomorrow. Fortunately, I have a fair few of those transformers in stock. So, thank you for your time and interest. Please join me again for part 3 in this repair series. Until next time, bye-bye.